All right, so let's start it just a bit of housekeeping. I still have yet to complete the assignment 1 marking, but as things are rolling as we go. But the thing is, assignment 2 is due tonight. But the thing is, we need to get you will get both assignment 1 and 2 back, probably 1 before that and 2 before Monday tutorial. So that means somewhere Monday mid-morning. Okay, while driving down here, I should be able to release them before I come. Yes, so because we're going to have Friday kind of intensive marking. You will see them. The tutors are inside the lab. I'll be back in Launceston. Yes, so I have a couple of meetings, but it should be better than last week. Last week I have to travel on Friday, and that's the kind of things that I get you often. I have to go to Bernie to meet with a couple of people. But that means by Monday, when you're in the middle of your group project, then you should get your hallmarks back. Okay, and yesterday I forgot to mention that you're probably not relevant to people here that much. Is that some people who get a supplementary exam, you will get my notification on Milo. Okay, it's an announcement because they happen to have a sub exam on KIT 712, I believe, happen on the December 10 on Monday. So those group that affect, so I put a criteria in the announcement that you need to have at least 2 of your members affected by it, not just 1 person. Okay, so what that means is that you have a group of 4, so most likely 2 person will be half of your team. Okay, if that's the case, if you qualify for that, then you practically have 24 more hours. Instead of submit Tuesday night on 11, you submit on the Wednesday night on the 12th. Of course, we try to get the marking of assignment 3, which due next Tuesday night, back to you by Thursday before your final exam. Okay, so that means that if you submit late, then you probably heard the result a little bit later. Yeah. But I think it's probably only fair, because if you have to prepare for major assignment as well as prepare for your sub-exam, it's probably I think it's probably okay. Justified to have an extension. And I talked to the degree coordinator, our BICT and MITS coordinator, so it's okay. But those only the team that actually affected by it. So don't get the 712 just for that you can get extension. So make sure that your team is actually there. All right, so I think this one is the one we finished yesterday. Okay. Probably you get a sense that some things are changing and things could have new effects. I think this one, just before we move on to finish this slide, to finish this lecture, this set of lectures, is that I think the real-time communication of these 3D avatars is coming on very quickly. So you will see a lot of this start to come up, but probably not in a full setup like this, because this setup is really in a research environment. Okay, probably not going to see most adoption outside the lab. Okay, so hopefully you can keep an eye on that. Okay, now we do a simple case. They study a few case studies, which is a couple of studies there. They study about what is the AR conference difference than normal video conference, which is look to us. It doesn't look like polished, but the fundamental question that they're looking for: how is the difference? Okay, between you are using this type and between you're looking at a static screen. Okay, so that means the task, the design, okay, is discussing the image in front of them. Okay, that's what you see. Try to get the mouse here, so hopefully it's recording on my media. Okay, so that's the image. So they try to have 2 people. It's you and the person on the screen on the AR conferencing, and you have 12 pair again. You work 2 of you working together. And similar thing with yesterday is that they define predefined condition for comparison. So in this case, it's audio only, like telephone. Okay, there's no video visual. Okay, and video conferencing. Okay, so that's something like this. Video conferencing is like think about it's like a Skype. Okay, it's like a static looking at the screen. And this, what we see a screenshot here, is really about mixed reality. Okay. So with this, you can see that. Things have been moving around. Okay, so in this case, you will see a different view. Okay, so this one is what they will do a simple study to look at what the present rating. Okay, so in this case, after the study, after they finish the experience, and then they basically ask them to rate. Okay, so in this case, it's rating between what's their feel or presence of their partner, remote partner, okay, how they feel about it. So even though this is essentially a subjective opinion, so that means you have them ranked, so they just kind of give a questionnaire. So you think about it like a survey. You say, okay, what your experience look like. As you can see here, the present rating is, the published paper on this one is slightly higher than video conferencing. Although some of the technically, this part, something like this, it look higher, but if you look at the qualitative study, the nature type of study, which is only have 12, essentially 12 pairs, so essentially a very finite, low number of points. This one typically, statistically, you need to run a statistical analysis to look at whether this one consider the lower number of points, whether this has statistically significant. Okay, there's quite a mathematic to calculate for that. Ballpark on here, I think this is not significant. Not statistically significant mean you can't tell this is more than the other. You can tell the mixed reality case has a higher presence than the video conference. Okay, so close. However, this one is the one far down. This one you could say is statistically significant. That is lower than the other two. Okay. So that just gives you a sight. But this is usually when you get to try to publish paper. It's not indicator like this is enough for presenting in a lecture, but it's not enough for publication. You need to run some analysis on top of it. So that's one thing on the left, present. Okay, so that's a subjective opinion. And then this one is a basically asked question. Could tell the partner was concentrating. Okay, how would you tell that your partner is concentrating? If you're talking to your friend, but I think nowadays things are shifting. It starts from command line, going to graphical user interface, mobile platform, now come back to micro chat, WeChat, so now it looks like come back to command line again. So nowadays actually this symbol, the emotion icon, those kind of things become more popular. So no longer people pay attention to their eyesight. Okay, so, but this is where you're actually looking at a people's face. Okay, so for example, have you been in a lecture where a lecturer has to teleconference in? No, not really? Okay. So that is actually, you'll get this sense that the lecturer part, I used to teach usually remotely, which didn't go quite well because most people were kind of, I can't really concentrate on students because maybe at that time video conferencing is not so good. Okay, so that means this is not far ago, 5 years ago. Okay, so I can see people like a few pixels. I can see whether actually the head is on the flopped on sleeping or they actually pass out on the back or something like that. I can tell that much, but I can't really tell anything else. Okay, so that means that when I try to look at them, it just doesn't make much sense for me. It's like in this time you can see I can try to pan my eyesight into different people without make them uncomfortable, not long enough, and that's a tip for that. But this one is actually, what you can tell is that you can't see, let's say for example this one, okay. So in this case here, you'll be looking at the person, okay, and the person be looking at you. So so that means that where you're setting cameras is important, okay. So in this case here, he himself will have hold the camera, the other person will have the camera look at them, okay. So in this case he will stand looking at the monitor, that one. And then he would actually moving around with his viewpoint. So, okay, in this case, it's actually, the experience is halfway, but from this experience, it's a full mode. So that means you can see him looking directly at you. Even though he will see him, he will see you from the direction in which his camera is pointing. Okay, so in this case, he would just see this space. So that a little bit kind of a tricky part, but at the same time, you can make the move around, right? So that is something that actually start to have some significance. Okay, so but again, these tools are really, the number is really not that far apart. So this is no statistically significant. Okay, but this is way down. So, but that is normal. So, okay, that's what you expected beforehand. Is that you're using phone call, then you practically have no idea how people are concentrating. Okay, except that you just have to read the verbal cue that they provide. Even that is still very tricky. Okay. So in the case 2 here, okay, can AR spatial cues aid comprehension? Okay, this is a more deeper questions. Just a minute. There's someone else using this room as well, but I keep moving this thing back, and someone else keep moving the other way. Okay. So the task here is recognize word in the spoken phrase. Okay, so this is nothing to do with our conference that we had before. Okay, this is someone play an audio back to you, and you try to recognize words inside what the thing that people talk about. Okay, of course the same language, English. Right. The condition here is number of speaker. You have only one person talking. So okay, what we're talking about here is what's the spatial sound look like. Okay, so 1 person talking, 3 person talking, 5 person talking. Okay, so that's your conditions. And this is audio here, spatial, non-spatial. Okay, so spatial mean the audio like a stereo sound. Okay, 5.1, 7.1. So that means you can tell where that's just like in a movie, you can tell the character moving from left to right, things like that. Okay, or you actually just have one single voice. So in that case, just like you listen to audio straight that doesn't have the direction. Okay. And the visual and non-visual cues. So this is really whether effective, whether you have annotation, not annotation. Okay. So this one is actually a very interesting result. Okay. So this is spatial sound, non-spatial sound. Okay. So that's the number of speakers. Okay. Speaker here could be people who talking, unique voice. Okay. Whether actually, if you actually have a spatial sound, that means you actually can generate the sound based on where you're located. So if you, let's say in this room, have 3 people talking, and I'm the main character, I'll be moving myself around. So that means I can tell which sound is come from which direction. Okay. That will consider the spatial sounds. And non-spatial sound just means I just hear only one monotone from one direction. It's the same thing that you put the ear set into 2 of them, but it's the same sound coming from it. Okay. So that is actually very obvious here, is that as you have only one speaker, it doesn't really matter. Spatial sound, augmentations in this spatial domain and audio doesn't make any difference. Okay. Whether it's actually, you can tell whether it's come from left or right, or it actually comes straight to you. You can tell what they are. You can, because remember the task that define is recognize words in spoken language. It does not ask you, the task does not ask you to find where they are in space. Okay. That's why the number one speakers is no difference. So it doesn't really matter as long as you hear them. Okay? Even though they're non-spatial sound, you can't tell them where are they, but you can tell them what they're saying. Okay, so you can see this one is very obvious. You can go number 3, number 5, the whole thing drop. Okay, so non-spatial sound, then it's very difficult for them to make words. Okay, so what that means is that if you record people talking, 2, 3 people talking, and then you play back in a non-spatial sound. So that means you just play back as it's in the same room and sitting together. Then it will be harder for you to recognize word. However, if you put them in spatial sound means okay, you actually sit in environments and you can actually sense that this person is from this direction, this person is from this direction. Okay, that's when you actually can tell better. This is just one of the studies to look at human perception actually has some limitation. Okay, and the way you play it out for them, the way in this case related to do a spatial sound here, you do need to recognize where you're standing, where you're tracking, where your positions are, okay, and how to render those, just like the sound system in the movie theater. Okay, so they will actually have some of these components in there. Okay, so this is just give you a sense of what. When you're talking about here, you have to consider some of these as well. Okay, the collaboration. Remember, this lecture is about collaboration. Okay, you collaborated, but then what happened is just not one-on-one. It's one too many, 1 to 5 people. Okay, then these kind of conditions is actually important. Okay, to consider that this is something that you have to add into it. Okay, so this is the end of this lecture. This slide, at least today. Okay, so now, is there anything, any questions? And I've been checking the recording. Recording sound is okay, so everything is okay. So I would suggest that for exam review, which generally that's when people start to open up the recording, Of course, I wouldn't recommend you to listen to all of them. I would suggest that you look at the slide first, okay, and you're kind of not sure what this page is look like, and then you can go into the recording and you kind of skim through to that page, and you just kind of listen around that area. But oftentimes I have to admit that I usually stay off the topic, so it might be the slide, but I talk about something else. Yes, but I think that's probably the way to skim through it. Is just get, I would say there's a few moments in there that are actually important for you to understand it, but a lot of them will really provide background. So. All right, so this one is really, this lecture is about authoring. Okay, toward the end of this lecture is about usability. Okay, they are building up for assignment 3. Tomorrow I will talk about in the lecture. I will release the assignment tonight, and then tomorrow in the lecture we'll talk about that. And then in the tutorial, that's when we form the team. So I'll tell your friend or those who want to team with you to be the same team to show up, because if you are not showing up tomorrow, then we're going to really have a bit of issues in forming your team. And then by the time you realize you have no team, it's Monday. And Monday would just basically tomorrow, the next day is a due date. So, and there will be no extension based on that you have no groups. So therefore you ask for extension. No, you can't do that. Yeah. So, right, so this one is actually authoring. Some of these applications that you start to see emerging in App Store, in not the mobile App Store, but a lot of in mobile App Store as well. When the technology getting more mature, then what's the missing bit? In a lot of this, it still has a lot of missing bit here, is that technology is advanced, technology, engineering side of it. Okay, those interface technologies are improving. Now, one of the key that's missing here is the content. You have a bunch of engineers, computer science, are building all this fancy tool, but essentially nobody uses it because they don't know what to do with it. Right, so that is actually, we are sitting somewhere in that period. VI has a little bit more, but this is not the authoring is a solution, but authoring is a way in which people are trying to build a tool, not just to make the tool make the VI happen, but make the tool that run in VR that allow them to authoring their data. Okay, so I mean generate data. So you'll be talking about data, how to generate content. Okay, so the authoring here is one of the way that people think it might be the useful way to people get them involved. For example, how we get VR for artists to use. So you need to build a tool. You're not necessarily going to be building, give them a tutorial in Unity and have them spend a few months learning how to do Unity. You basically, as a few getting more mature, okay, then you will build a tool that allow them to alter. That altering, I mean, they provide their content, they get their creative idea and provide content inside the VR. So you build a tool specifically for that. But before we go along with that, we should understand a little bit of what authoring look like. Okay, so this is basically this is a more technical definition. So this is authoring is around process. Okay, you analyze, you have structuring, you have description. Okay, this is a 3 kind of component in which you are looking at. But then authoring inside VR and AR conference, VR and AR condition environments, this actually has all these parameters changing. Okay, so this is where you actually think a little bit. Authoring in a layman term is you're writing a paper, you are writing your note, your transcript, your personal note. Okay, this one is actually you alter some of the contents, you become ownership of that. Okay, so, but then. This is where I think quite a bit of a change coming into the field. That's why it's only happened this part. Content authoring really come back when the field getting more mature. Okay, so right now VR is practically sit inside that period. It's that the technology start to be more mature. Now people are thinking about what to do with them. Okay, so this diagram to show you that actually initially you drive from the left. Okay, so this is a technology driven. Okay, so you have programmer, engineer, those scientists that building this component out. Okay, so it become the tools available, Unity, Oculus, those kind of things available. But then on the other spectrum that comes from the right hand here is a pushing by the design. When the designer here, I mean interaction design, application design, industrial design. Okay, so they are coming from the content driven. So basically they will have full of idea, for example, in marketing. You have a lot of content in your head, what you're trying to do. So you're going to have to try to find what the best technology to do. It used to be QR code, website, YouTube, those kind of things. Okay, so that's why when the new technology comes, these paradigms need to be bridged. So it's coming from the left to the right, so you need to be bridged in the middle. As the core of these units is somewhere somewhere in here, if you think about it. Okay, so we know a little bit of technology. We try to driven by the content in which we think is relevant, and we try to find those bridges. Okay. But this is where I think the tool that actually allow them to create contents to become critical. Okay, so the next thing here is that what is authoring exactly? So if this just come down to this, so basically create an experience without the need of programming. So basically we just avoid programming at all costs. Is that all the, it sounds like from this diagram, it sounds like, okay, that's what you do. You don't want to program, so you just want to be the one to create content. So, of course, you not look like this, but essentially this is what sort of say, okay, authoring is a little bit more than that. Okay, if you pay attention to the diagram here, it's not necessarily, okay, you have content, you find match technology. It's actually, there's a process involved in that. Okay, and that's what we covered this last week about the process in which to match the technology, demand of the application, and those kind of things. Okay. So now the issue, one of the factors that we key concept of this is called affordance. Okay, this one we talked briefly, I think last week. Okay, so this is the quality of objects that allow individual, which is us or anyone that look at the objects, to perform an action. Okay, so this is a perception part of it. So affordance, so what you see, what you actually think you can do. Okay, as I said before, in interface design, high affordance is one of the key sought after quality. Okay, so you don't want to design the interface that has low affordance. So that means it's really hard to see the low quality of people know what to do with them. Okay. So, so the relevance of affordance. So in this case, is a compare between the two paradigms. The WIMPs, the Windows icon menu pointer, which is essentially that's what you're using now. Okay, and virtual, no different between text processing and 3D modeling. Okay. So in this case, in terms of relevancy, so you can see this is a very old type of interface, okay, which is essentially same with a relatively new Windows. Okay, so you can see here, it doesn't really matter. You can use for simple thing like Word document, or you can use some for programming with high graphics. Essentially, affordance are similar. Even actually, the more complex it gets, the more it works on the traditional display, okay, traditional interface, okay, so icons. You can try to tell that actually it's much harder to learn, for example, 3D. Anyone have experience with 3D modeling? 3ds Max, okay, so SketchUp. So those are, you need a bit of learning. SketchUp probably not that bad, but the 3ds Max is require a bit of learning, okay. And that is actually a classic example of you try to get your interface, existing interface, which is a mouse and keyboards and everything, try to fit your complexity of your task inside that window, and that become sometimes it can become a little over beyond what it should be. Okay. Now, if you're talking about in the context of our unit, so something like this is a good thing to get you thinking. You have a kind of black box, white block exercise here. Objects here that look like you can hold it. There's a few buttons. What is the level of affordance? Okay. Remember, the affordance is divided by the quality of the object that allow you to perform the task. But if you just, someone gives you this object, foreign object, you don't really know, there's a stick coming out, so you start to pressing them and randomly and see what happens. All right. So affordance here is actually, that's what I think we define this unit in the AR, especially in AR. Okay. It's actually affordance in context is what we're actually getting. Okay, so in this case, the same device here, but then you have the visual feedback, you have the context in it. Okay, so in this case, that's what affordance AR can bring, because AR has even not just AR, but it's also in VR that you actually have a visual feedback. You know what this button press and what it does. Okay, how to interact and how does that actually reflect into what is real world projection. Okay, so what that means take home from this page, from this slide, is that in AR and VR, forward and true context is particularly very important, okay, especially for AR sites. Okay. As I said before, you can put the virtual object, okay, in the middle of space, like what AR is supposed to do, like your Fourier is supposed to do. Just ignore the marker that you have. Okay. You can seemingly have it pop up, right? But then understanding that, that's why I would pay attention to a lot of Fourier project, that you need to pay attention to the design of your marker, of your image target, because they are the one that actually provide your context. You don't want to use a standard marker, the astronaut on the Mars, and then you try to pitch this as a zoo, and then it's sort of like the context is not there, and then therefore they phone the character what they're supposed to be, elephant on Mars, and things like that. So that's why I think you need to change that. But in the process of doing so, you try to create this, what they call a forward and true context. Okay, that's very important for our unit design. Okay. So this one is a type of affordance. Okay, we have actual affordance. Okay, it's what really happened, okay, what is really actually do, and what you think is due. So the second one is perceived affordance. Okay, so what you want ideally for this one is the two of them to match. Okay, so what you think it works is actually is work that way. Okay, so let's look at the example here. Of course, we can guess what this is, right? So I think we practically have really confidence. So this is say something perceived is like, oh, this is something that you can open, right? But then in the actual it's good. Okay, actual is that actually let me through. This is actual. Okay, so this is somewhat is along the same line. Okay, how about the next example? Okay, so this one perceived and actual. What do you think? It quite matches quite well, isn't it? Yes, so even though it looks strange, yes, but the perceive here is that, yes, you're actually looking at something that will get you from point A to point B somehow, okay, yeah. And then the actual is that that's how it works, okay. So this is where I think just try to get the message that actually it doesn't have to look nice. Okay? Interface here is not about artistic design, but it's actually about functional. Okay, so in this case is that you see it, okay, I bet this is a transportation. Let's say someone landed you here in this country, that you have no conceptual of what this is, but you start to see the vehicle moving, and you start to see that, so your perception of that is actually already there, and the actual is to turn out to be that. Okay, so this would mean this is a very good design. Okay, now, on the other hand, when we think it's a fancy thing, it's oftentimes lead to a better design. Okay, so that is actually usually what you have in here. This is when, in fact, the input and the feedback is opposite. Okay, I point out quite a bit of time. This is a difficulty for people who try to get into this area, like elderly who try to use computer, a normal mouse and keyboard computer. So you can see he looked at the screen, but the contents he looked and the content that he interact with is actually somewhere else. Okay, so it's really not in that location. So he had to transport himself inside that space. So his input and his feedback are really different. Okay, so the feedback here, what is the feedback here? Feedback here is a display. Whatever he interact, you'll see the screen changing. Okay, just like we working on computer, that input. Okay, the reason is actually you are doing it now because seamlessly, effortless. Now it's because you're actually in that environment. You train yourself. Okay, but if you look close enough in there, there's some people that type faster than the other. There's a certain different skill. So that means that inside there's a certain bridge or what we call a seam that actually allow to kind of prevent you to work completely with full potential. Okay. So that's what I think we're looking at, something that actually can merge the two of them. This is the classic example this year, is that you input your human input into it and you get the feedback where in fact you are looking at them just like you interact with a real object. Okay. You know that currently how you operate with the mobile phone is actually this mode. That's why I say again the example for the elderly, they have much easier time learning iPad rather than the normal computer. This is simply just a basic concept. Okay, so basically they look and interact of something that in front of them and give them the feedback. So in this case, the channels is actually straight. Okay. Is it early in the morning, is it? And the late night too. All right, so the authoring here is the different level of authoring. Okay, so you have a desktop, you have a VR, AR on top of this. Okay, this just gives you a multiple layer in which you should think in terms of authoring. You should think of this layer. Okay, so initially you have to start with this domain knowledge, right? Just like I asked you to pick the theme. Okay, in the report for assignment 2. Okay, a theme, tourist, scientists, data visualization, and whatnot. I think you just have to have that space. Okay, and you have this desktop volatile data. Okay, so in this case, it's the data. You can actually move them around. They have many forms. Okay, so then you move up a little bit, get inside the VR medium, which is now actually interface chip. Okay, you no longer look at the interface the same way that you look at the desktop and mouse. Okay, so in this case here, there's elements of spatial data. Okay, so in that, before you have spatial data, you can run into this, but it doesn't have dimension that actually take advantage of how you see. For example, you could look at scanning of this room in 3-dimensional space, but if you look on the monitor, they just simply be an object in front of you, and you just move them, even though you make sense out of that. Okay, but you're not really fully use relationship of the 3D spatial data. VR enable you in one step to be spatialized. Okay, so in that case, that you'll be able to put the data where it's actually supposed to be. This part of the building, so you have to turn your head to the left to see this. So that's the data becomes spatialized. Okay, if you look at the screen in this desktop, you will just see them straight. Okay, you can rotate them around, okay, but you have to transport mentally to see from inside. Okay, but this one you actually do less of that. Okay. Just like you inside, a lot of you do VR project, you transport yourself into a forest. Okay, so I think some of the projects do that. Then you practically can see, okay, that's a tree, this is the next one. Okay, so that's one. Try to think about if the task is more complex. Okay, simulation is more complex, then that's actually specialized ability would be very significant. Okay. And if you move it up in this context, then you start to different between AR and VR is that AR is actually now put in environments. You have interaction between virtual content and the real world content. Okay, so that would mean this is contextualized, just like what I said before a few slides earlier, afforded to context. So in this case, is that where you display information become important. Mm-hmm. Yes, okay, hopefully that kind of simple steps like this is good. You understand. So you have a data. If you have a spatial data, VR could be a platform. If you go up a little further, if you have the spatial data that you require contextualized inside it. Contextualized doesn't always mean real world. It could be context in which, for example, in your euphoria. Contextualized is actually your marker. You keep them a contextualized. Okay, so that's the important part. Okay, so therefore, yeah. So I think hopefully you can see the step here. Okay. So the affordance and altering here is regularly go hand in hand in the concept. Okay. So that's why one of the design that we talked about before. Okay. So it's a match of object affordance to task requirements. Okay. This is particularly important for your assignment 3. Okay. So in assignment 2 are really just to try to get you to have a success, positive experience with the whole thing. The design components is not as strong. Okay, I won't mark strongly on that sense. But in assignment 3, you do need to get this part strongly because you have more than one head, hopefully. So you get to brainstorm it. You need to make sure that these parts are really, really what it is. Okay, so just like assignment 1 is a precursor leading to assignment 2, it gets you to think how to address strength, weakness. This one, it really gets you to think. The next one is that how to do a better design. Okay, so if you're thinking of using your existing project from one of your members, which I will talk about, it's option. You can use one of the project if it's very good, your teams really like it, want to improve it. This is the part that you also need to significantly improve that. Okay, so yes, so assuming they still have something to improve. Okay. All right, so have a think about those. Okay. So this one is in terms of tools. Okay, there are many ways of people are getting this component done. Okay, so that there are different level in terms of technicality. Okay, that's ordering tool itself. Okay, it's a very high level. So this one is actually require a lot of development work to create these kind of tools. Okay, in some way, Unity is classed as some aspect as ordering tools. Okay, because you bear AR, VR, or this kind of interface developer are not generally drag and drop. Okay? You actually deal with libraries and very hard, low-level code. This one are more or less very more that's why the concept that you're familiar with the prefab, it's actually useful. So that's when drag and drop and things like that, and allow you to kind of copy and paste it easily. Okay, but this is require a lot. Okay, a lot of content driven. So you're allowed to basically community to jump in and has a lot of content because you have altering environments frame. And then doesn't have anything that you do. Like for example, if you need asset store doesn't have anything, try to imagine that. That doesn't mean the tool practically it's a tool for you to build for yourself. So it's really not. There will be no content to help driving those. So require quite a bit of work. But the toolkits itself on the opposite end, the very top. Okay, that is when usually most computer science are working on like AI toolkit with the marker and Japanese character. That is actually a toolkit. Okay, that's when you download it, you build application that come with a sample application. You just build your application. You just build your program around it. That one created in C, so you just have to build from scratch from there and then access the library. Okay. And the framework is somewhere in the middle. Okay, it's framework somewhere in the middle that you can load up your custom code, your toolkit code inside, and incorporate it. Okay, so this one in some way, in one side of the Unity, is look like a framework. Okay, so that means if you have your prefab that you build in your program, you can actually export that and give it to your colleagues, and they can import it in, just like the way you import the prefab into your program. From those sample framework, they use a lot of prefab that you notice inside backend. So that would be a kind of playground when people have content, they're driving to it. Yeah, so and then they start to play with those. Okay. And of course, this one is the one that more on content part generator. Okay. So in AR, people has been looking at using this tool, this kind of a paradigm thinking to be getting, or how can I use these to be altering tools for AR? Okay. Right now, anyone explore the? Have you looked at the apps on anywhere application that actually can allow you to do easily content generator for AR? Yeah, Pokemon Go is an obvious example. Okay, so and I think Snapchat, right? You might have heard of that. Yes, so they also provide some of those. So essentially, your content exists inside Rio for people to look at them. Okay, so but there's a more technical work that done earlier about this. The same thing has been on this, but this just gives you a sense of what is the current what it actually can do. So in this case, I'll show you a video. I lost the original clip, but apparently someone posted it on YouTube, so I'll display that in a little bit. So in this case here, you can use this device. You can use this to manipulate, okay, changing contents. Okay, this is a part of a way to get into those space. Okay. Oh, just give me a second. As you can see here, so this one is actually allow them to change different object. Okay, so allow you to change the contents here. Without this tool, I think you have to go and then modify this on the code at the unit. And then in this one is basically you build a program to allow them to change this. So the reason I want to talk about this before you start working on assignment 3 is that this could be potentially one of the projects you could do. Not like this, but allow people to change the content based on what they need. Okay. So I have controller there. It does. I'm not suggesting that you have to go for this form factor. There's a lot of work you go into this one. Okay. So in your case, you could be talking about your VR, changing environments, and people around them to customize some part of your application. So in this case here, it's actually changing the attribute of the objects. Okay. is the change property. Okay, change the size. Okay. In some way, this is what you do in Unity when you modify the model. But what happens if you want to modify, have the end user doing this? And this will be the tool that you're actually using. That will be kind of looking to look. So user is the one now to modify. They don't have to go back to your Unity. I think it's nice that technology is primitive, so you start to know that actually, start to see easily why would they need to do this, okay, not to showcase what they can do. And then now they're going to try to connect these two together, two properties, okay. The concept of this is powerful in the sense that actually, think about it, if this is replaced with a marker that's more relevant, like blue Fourier, okay, so the marker with full Fourier, you can actually make this kind of randomly marker to have meanings. So that provides a solid context into it. The example could be a memory card that people played before, but in this case it could be something else. It could be the way you more complex issues. So this one just showcases how to control the virtual elements, okay, using a tool that he built. So this is from Korea. This is from a good colleague of mine, Gan Lee. He now is with the University of South Australia. You see, this is changing the speed. Okay, so this is, I think, it's a very simple way to demonstrate that actually you can turn, and if you put the context right, the contents become more available. Okay, and more engaging and more allow people to do quite a bit of few contents together. And this is, I think, is a throwback into his memory card game. Okay, so you have. So some simple things like that. Okay. So if you have this one is driven by a simple story, a childhood story. Right? So that would mean think about those. So hopefully this gives you a kind of basic idea. Okay. So what might be possible. Okay. So instead of you try to look for end product in games. Okay. This is experience. You could be looking, one of the things you could be looking at is altering components, make people user ability to adjust contents, customize contents. Could be really simple, changing color, those kind of things, really relatively simple. Okay, so but that would provide. You need to provide suitable context. Okay, what application for, that kind of things. Okay. So in summary. Okay, so altering is rely on context. Okay, as I keep saying this, spatial, social, logical. So you got to have some things. Okay, it's not just where located this corner, this table, or that corner table, but it's also social components of it. Okay, so this one is that whether you build the apps is actually appropriate. Okay, we haven't talked much about the ethical design implication of the design. You don't want to produce an application or interface that actually provoking certain culture. Okay, so these are the kind of thing that you have to think about. Okay, so and also the message itself. Okay, whether it's actually the affordance, which is the intention of interaction, what you design for, what it look like, what you want the user to perceive. Okay, and the ambient, which we'll talk shortly about this. Okay, briefly about this one. Is ambient is something that you're not. When you see the light, or not, when you see the interface, you don't actually feel it much. Okay, so this one just gives you a bit of flavor. I give you a glimpse of it at when I talk about TUI before, when you have this rotating fan with different color. Those are kind of ambient components of interface, which is, some of you could think about that if you have the idea in artistic component. Okay, it's not necessarily what button I need to press, but it's more or less how you want to feel it. So this is what this term has not really taken off, okay? But you would have seen this in a kind of installation art design before, okay? So which is some of this we'll also talk, I'll show you about that, okay? Affective computing, okay? So it's not a E, it's a A, okay? So this is affection, emotional attachment, those kind of things, okay? So make computer aware of our current mood, emotion, okay, and predicts intention by capturing, interpreting a variety of sensor data. Back end of this is a whole bunch of sensor. Okay, I tied this to ubiquitous computing before, IoT, Internet of Things. So those actually kind of bundle into this kind of interface. Okay. So the diagram could be something like this. This is put together in two sides, AR and effective computing. You can see here the one on the sensing side, okay, which is on the blue blocks, blue color box here. It's essentially major part of effective computing, okay. So that is a capturing real world, and we are part of real world. So it captures our emotional, biological side and everything we can use, and basically try to interpret what we're doing, whether we get exciting or on the right hand side here is actually how to actually get people to see and show them what we are detecting and potentially could influence them. Okay, so this is where the AI and effective computing actually have a role, kind of complementary roles in each other. Effective computing is about gather information. Okay, without user need to be proactively do it. Okay, so that's why the word ambient can be used as well. Okay, but AI is really about get them to kind of try to see what the outcome of what you're detecting will look like. Okay, so this is intention. Is what's the point of collecting their data? I mean, if your point is try to moderate or changing their behaviors, then you have a way. What AI is one of them to get changed. AI is not necessarily the only one. Okay, it's just a good example that you're using that. All right, so for example, like this, okay, so interpretation is extremely, sometimes can be very technical, okay. This is already work from the doing image processing purely, but nowadays a lot of hit tracking face and everything is done commonly, okay. So this one is just not what Facebook apps, Messenger apps is that put your hat on your face and things like that. It won't do some of these. It won't be able to tell you, hey, are you mad, are you confused, but this is, you can see here, this is from image contour of the heat map on his face. So you can see as his face is changing, moving around, okay, he actually, his computation, this one is not straight come from his face. This is go through a specific algorithm to process and help this outcome. What they were looking for, intense area of face, to try to determine the bottom line here, which is what exactly are they not having emotion? Let's say you want a computer to detect if the user has questions or have problem understanding of what they were just saying. Like let's say a computer will notice some the unusual or surprise factor and their questions and things like that. So this is just a attempt to try to understand those. As you can see here, the key criteria here, the user doesn't really intend to do anything. They just kind of act normally. Okay, and this is how the researcher try to retrieve those information and interpret those information. Okay, so anything surprise you? So, and of course, all these things are based on classification. Okay, so this depends on what patterns they look like. Okay, so this is just a clear, very clear peak difference. Okay, of course, you will get the sense that you will get in the case that they're kind of overlapping. So in what case that you think is most likely to overlap? Which of the two cases here? Of course, this is already the peak difference, so it's really different now. But generally, happiness, you can see his signature here. Okay, so this one and the happiness, okay, there has this component that if you're not super disgusted or is super happy, you might actually think it's the same thing. So that means if you run this algorithm, sometimes people think you're happy, when in fact you're just simply the other way around. So this is the kind of sensing that actually are always difficult, but this is one purely based on image processing. Okay. But nowadays the technology has more components. Okay, so people now start to look at eye tracking, how you sweat, and your heart rate, and everything. Okay, and all the smartphone that you have, and actually that's become part of some of these as well. And there's no, just like in the tracking that I talked on Monday, there's no single one that's going to tell you this is what happened. This is just a attempt by a researcher, give you a foundation. But nowadays they rely on multiple things to tell you multiple clues to find the most accurate estimation of what's happening. Okay, so there's multiple sources like a hybrid solution. So this is just as you can see here, this is going to be extremely hard to try to find what is the robust way of determining this. Okay. One of the things that you might not notice, this guy always looks straight at the camera. What happens if he's not look straight? Now his will change significantly. Okay, so some of these is actually, there's quite a bit of a technical that for you to do research in this area. Okay, so you need to kind of have a set that you can control very well. So in this case, you should control, one of the control is the face direction. Okay. Just that means that it's just a lot of work, more work. So this is some of the work that you might have seen, the respiration, I think you've seen that, transform, and then you have the V remote, so all those that can tell you, okay. So even the hand controller on the wrist is actually can tell you which button you click, things like that, okay. It hasn't yet gone so far as tell you what, are you sweating or what your heart rate, but in fact it could. Your wrist controller can tell your heart rate, okay? So your eye set here can track your eye with insight. Okay, tracking your eyes actually can provide you a more accurate estimation of the state of mind. Okay, if you look confused, your eye will kind of move around quickly. Okay, of course you need to have a baseline, but what I'm saying is that what you're actually playing with now is just entry. Okay, because people are now working on capture the eye gaze inside the Oculus, inside any VR headset, because that's what the missing gap in what we tell. Right now we're just looking at they just treat the user as a box that's actually moving the head around, which is that's already good for the most components used. But to go to really full extent, you do need to capture the intent. Let's say you say, okay, what's your intention? The best now is that you should capture where your head is going. But in fact, your eyesight could be all over the place. Okay, so that's a different pattern, different people, different. That's why this kind of study always require, for individual participant, always require a baseline capture, because someone could have, we all have different type of eye movements and gestures, movement, walk differently. Okay. So all this is actually part of this. So now VR in general now is start to emerge in this space. Okay. So this one is actually look a little bit out there, but it's basically talking to the tree. And the way you talk, language you use, reflect how the tree grows. Okay, that's how could be something that interesting you for the assignment. Okay, let me show you the videos. Somehow it doesn't run inside the PowerPoint. So the guy in front is actually doesn't know what he's talking about. Doesn't know what he was looking at. He would keep talking to a microphone. There was a camera capture his emotional state. So he doesn't sound sincere, so the tree is actually grow differently. So it's supposed to be, if you're angry, if you detect the angry, the tree will kind of go a different way, or maybe chopping and leaf came down. But this one is actually, I just try to show you that it's actually, you see there's no button to push. Okay, it's just simply reacting to what you have, and that's a good example for if you pitch for like ambient interface. Okay, which is some of you I think you might be interested in looking into that. Okay, so because it's really well, technology-wise, I think it's a lot of work. Okay, but in your case here, if you want to do some things like this, you're not going to have time to do any of these. Okay, so what you actually be doing is that you be do mock up the case. Okay, so for example, the tree here could changing, but you can actually changing based on a fixed sequence. But then in the report, on the design report in the assignment 3, you can say, okay, this is how, when people interact with it, this is how it goes. Okay? So that would mean you just simply make a content that have a certain way of changing, and you just pre-program into it, and pre-set into it. That's it. And that you can actually make the story, the other story, inside an effective component, effective computing component. All right, so hopefully you get a bit of idea. So I'm trying to give you a few things for you to think about. Because as assignment 3 kick off tomorrow, if you don't think early enough, you won't get a chance to think. That's the end of the day. So because by the time you see each other, if your groups are not working well together, then it will be Monday before you meet again. And that will mean, oh, no idea what to do, let's do something. And that's when the idea will go down really quickly. So this is hopefully seeing you attend lectures, and those who listen to my voice shortly after this, then I should get a chance to think about it. This is not about creating a active, proactive option. Right, so the effective use of this is actually adaptive learning. Okay, this is a big issue. Okay, will come. I mean, some of you will be a driver, hopefully a driver for this. Is that especially in the classroom, is very applicable. It's that we have different backgrounds, we have different prior knowledge set. So therefore, this actually right now they're being looked at a much earlier age, like in the primary school, okay, when you actually have kids that start to kind of fall behind. Okay, so this is where you require adaptive learning. Okay, so in this case, it's somehow typical learning. It's still up into university. We hand you assignment, and you just try to complete the assignment. Okay, and this is not saying that adaptive learning means you don't do assignment. You still do assignment. The assignment actually customized for you individually. And that's what I think primary school is actually trying to look for that, because the rate of people who far behind, let's say they start far behind year 2 and year 3, which is about 6, 7 years old, they're getting behind and further behind. So by the time they get to year 6, getting ready to move into high school at about 12, 13 years old, they'll be having a hard time getting to, they will have a hard time has options. Okay, so they might not have good option for them. So that's why adaptive learning environments is actually key, because they find that children or human in general perform better if you want to learn, if you yourself want to learn. Okay, so what that means is that having assignments is good in terms of measurement. Like I measure how much you know, but it's not very good in motivating you to learn. Yeah, don't confuse about motivating to get the assignment done. That's a different motivation than the learning. Sometimes you can, along the way, you can, in the traditional way, in the old day when I grew up, that get the assignments is actually how you learn it. Yeah, but those generations will know is that some people know it, some people now question, what do we learn mathematics in college? What is that for? We hardly use it. We use plus, minus, and divide, multiply, basic, and calculate basic calculation. But what about differential equations, calculus? And you have any use of calculus at the moment? Yeah. So those are really not. It doesn't mean it's useless. All the technology you're running is basically has a lot of mathematics running behind it. GPS is particularly a good example. Now, but the key here is that it doesn't, the way that we deliver the contents, it's just sort of like you have to learn this to pass this, learn this to pass this. So adaptive learning is really, and effective computing that we showed before, is actually some way to try to measure how students are progressing along. Okay, so if they lag behind, for example, adaptive learning, we need to try to look at that particular case, for example. Okay, and this will become a major issue for a lot of universities at the moment as well. Okay, so I mentioned this, the second one before, ARS installation. So this is a very obvious use case of this kind of technology. Okay, as I mentioned before, you go to museum or you go to airport, sometimes they have installation that based on projector, you run into something and there's something walking, being kicked a virtual ball around, and kids love that. So, but that is a kind of a tip, low-hanging fruit kind of options that you can do. But as the technology is moving to that is a real class, is actually how you learn. Okay? As I said before, adaptive learning here, in my personal view, it's not really about how you design your learning part. It's really about how effective you are to integrate AI, artificial intelligence, because they're the one that could help I call them they, but essentially there's a size of it that actually come and try to help, because for us to individual, even this class is 85, but some class has 200. So basically it doesn't matter, I could have another 5 tutor helping me, it won't be able to customize them for you. So you need a bridge system of people who actually monitor and has a system that kind of AI that actually mining the data, maybe give you a ballpark of this potentially this student has a bit of tendency to go behind, so this could be a class of that. Okay. And but that is a bottle, a big change for us. And now, I should take, you just got back, but we take a break. We're 10 minutes break, so see you at 10 past 10. let's continue. So this one is really about lectures, about 10, 12 slides, but it's about usability tests. This is usually where we spend a lot of time in my students and PhD students, honor students working in this space. Okay, it's a quite. It's not a technical component. It's about design, getting design, what you try to measure, and measure them, and then report the result. Okay. So the first thing is that you need to define what the target audience. Okay. As you know, the interface design, a lot of what usability is for is that you need to tell whether what you develop for. I think by now, I think everyone that's doing assignment 2 or assignment 1, you already know that actually that is one key for us. Almost the same thing. If you look at someone who asks you to comment on some application, okay, and then you could say, what is this for? Who is this for? Okay, so this become kind of a form what you actually try to do. Because we, in the interface design, we're still under the assumption that one interface is actually do only some case, only good for design a specific case. As I say, I believe in what AI could bring. If AI came on board fully, if one application with AI that adapting to what you actually need, it's actually be one for all. That's not yet here. Okay, so we just have to focus on the target audience for the time being. Okay, so that's 4 roughly evaluation paradigms. Okay, so first one, quick and dirty. Okay, this one is. It's not a dirty. Quick and dirty means it's just quick. It's not no dirty part. Okay, so no need to put it dirty there. Quick and dirty is really what you can be using for your assignment 3. Okay, so this is quick and dirty. Informal feedback. So the thing is, like you have a prototype at some stage. Okay, you don't have to go through the whole application, the whole thing. It could be some part that's working. You have to balance it out. You don't have to complete them. But what you actually want is to get informal feedback. Okay, so what you think. Okay, so but you not simply just turn it to them and then they just put it on and then they just, oh, I didn't know that what it is, but so they keep comment anyway. So there's some standard procedure that you need to kind of do so that allow yourself to get the information that's relevant to you. Okay. And that's one, and then that's why it's quick and dirty is what good. Okay, and then you step up. This is getting more difficult. Okay, usability test, and that's what most of the research is sitting in. Okay, in the lab control environments. Field study here, it's just like its name is saying. Yeah, you do similar thing, but you now go to the field where that application is supposed to be running. Okay, and then you have another one called predictive evaluation. Okay, so this one is when you're getting more mature. Okay, technology, you have done all this for 10, 20 years, and the field understand, the community understand quite quickly how it's going to behave. That's when predictive algorithm can be useful. Okay. So this one is just go a little bit more detailed into each of these. Okay, so quick and dirty. Okay, so informal feedback to confirm their ideas in line with user needs and alike. Okay, so this one is actually, let's say you design a tours. Okay, so application, but then the feedback is that I don't know what is this for. Then that's become obvious that either your app's something wrong with your app, so actually your feedback gathering session you forgot to tell them, you got them the important information what you're looking for them. Okay, so it can be done anytime. As I said before, you don't need to wait until your application is finished at Tuesday night to get the feedback. You probably, hopefully, you can get them quite early on, late toward the end of Monday, which next Monday I'm talking about that. So you have a time to write about them, okay, reflect about that. And so that means it doesn't mean that it's just one time. You could do multiple of them if you think it's useful for you. Okay, each one of them only going to take like 5 minutes. Yes. Because I don't think your application would be long enough for them to kind of, explore. Okay, so they will just go in there, and really depend on the question you ask them. For example, if you want to ask them, how do you, what do you think if this is let's say go back to the forest project, okay, the tourist project. Okay, do you think is this useful if you want to travel to, let's say, Port Arthur, okay, for example. Okay, is this useful? If, let's say, you build part of the Port Arthur, did this get you a view of the Port Arthur? Okay, so that could be one of the questions. Second one you could ask is that you think this app would be useful for you if you're not from around here, or you can pick the place in which it's far away from here. something like that. Okay, so that would be the question that you, in some way, is leading, but you want to detect the obvious problem in your design. So obvious problem is that, no, I don't think I need it because the applications really doesn't get me the feel at all. Okay, so you're missing this part. I don't get the feel, but even that, it's actually most of the time you will get something like that. Oh, it's almost real, but that's how you frame your question to get it. So basically, what do you think, even though this is a very early proof of concept, what do you think of this potential? How you frame your questions, okay? So you will never go into a quick and dirty and say, what do you think? Because you can get all kind of answers that come back, okay? So what you want is that make your question small, barely scope enough so that you actually try to refine those directions. Even though the whole app could only work on that part. And so you just focus on that part. So that would be an idea. Try to not think about quick and dirty as a final end of your design. So that means you have multiple iterations. So this one could be focused on one angle. The other one go forward another angle. But in your case here, just have one, at least one, that would be fine. Fast input. Okay, so some of these is technically you have typically in the normal semester you have a group work about 4 or 5 weeks working together. So that's when this one will become handy. You get the feedback along the way. It's much easier. Okay. You even get this input form at the stage of just still in the storyboarding. Okay, even that you can still get the feeling. Okay, what do you think of this? Okay. They will start to point. They might ask some serious. It depends on the quality of participant you get. If they really just want to do you a favor and then try to hurry to go to have lunch, or they just give you a 2-second line and things like that, then you won't get much from them. So, but in this case, you have 85. I think you're just kind of using the strategy that I help you, you help me. Helping doesn't mean that okay, you're good, your application is good. Okay, that's it. Actually is almost guaranteed. That's what they will say. Okay. But what you would really want is that, I think this application had this component that's missing. Yeah, so I think there's a missing part in your design. Okay. Can you take outside? Yeah. Oh, does that involve me? Oh, okay. So otherwise I can join in. Okay. So okay, what you're doing there? All right, so the quick and dirty, so probably you get them, quick questions there, okay. And this is a lab study, so this is where your most PhD and the most study will involve, okay. So this one requires a set of procedure that you define beforehand, often, and you need to set what they call an ethics application. In the university, there's an ethics committee to consider the kind of study that you're going to be doing. You need to get approval before you run this, okay. So usually we go with what they call minimal risk, the full ethic application for medical. Take a tissue, get you to take medicine. Yeah, for us, it's relatively straightforward. Okay. Although the VR headset has been tricky. If you try to use the VR, because VR has some potential to create you motion sickness. So there was a mitigation, and some of those had to be kind of carefully, because that ethics is, thanks to my group, they now start to aware that VR can make people sick. So now they start to, okay, can you frame this a little bit, okay, in your application? But this one is where, this is a traditional way, okay, you have participant here, so the record can see. So you have participant here sitting, okay, and this is C2 classes, okay. Usually is, sorry? What's that? One-Simon rule? Oh, yeah, one direction mirrors. So basically just like in the movie, you can only see from one side. Okay. So that is not really a secret room. It's basically to provide a distraction, reduce the distraction. So you don't see the other guy running around outside disturbing you. So basically he will see like he's sitting in environments. So in this case, it's really just how he used his application. Okay. So these are typically rooms like this. And then you see through, and then basically this is all the control, the capture, what you were doing on the fly, and this is all the team, research team, the looking. Okay, this is more professional setup. In a university set, you practically have a conductor inside the lab with him, and basically read them the procedure, okay, and then they follow procedure. Okay, and usually procedure involving, task performance, require them, okay, can you perform these tasks, and then describe to them, and then they just go ahead and perform the task, okay? Like in VR, for usually involving, okay, so we have application here, can you drop a ball here? Can you drag the line from point A to point B? And that kind of thing. They don't need to know the purpose. The subject doesn't need to know the purpose why you're doing this, as long as they're doing that, okay? So in some way, and then the control, another name is called control experiment. What that means that you control parameters. It's not just walk-ins, usually take months, usually take more time to prepare for and the design and prepare the experiment than actually the time to do the experiment itself. Usually the experiment will probably a week, 2 weeks, but you could prepare about 3 months. So in that means the step need to be nailed. Okay, for let's say you have 50 subjects go through, each one of them need to go through the exact same procedure. Okay, so toward the end you'll be getting routinely doing the same thing. Like I oftentimes tell my students, you just have to practice at one point and then turn yourself into a robot. You can just kind of do the same thing, do the same thing, do the same thing, same procedure. Because the cost of not doing the same thing is that if you miss some important step, let's say you're supposed to introduce this element first and then the other element later, and you have them skip them around. What that means is that it will impact the way they perform the task. For example, they're supposed to learn this tool number 1 before they learn tool number 2. Then essentially sometimes you do it so many times, you forgot. Then essentially they have difficulty, the task that actually require task number 1 that you just skip. Even though later on they discover and then they relearn that part. Yeah, so but this is really screw up your data quite badly. Okay, so if you have done that, if somehow accidentally done that in that, like you miss procedure and you miss a step, generally mean that subject participant data just have to be excluded. You cannot integrate it in. Okay. So you can see here, there's quite things. So first you usually start with hypothesis. Hypothesis is that your application is cool. It's probably not a good one. So because that's very hard to prove. Even though all participants say it's cool, but oftentimes most of your participants are your colleagues, are your lab mates, classmates, schoolmates. So of course they will tell you cool. So because if you tell them bad, then they just wait for their turn to tell that your app is bad as well. So this kind of go around. So this has a bit of bias into it. So hypothesis is a key. Okay, it's a key to get this study right. Okay, so something of a kind of a practical hypothesis, for example, I want to know that these apps can perform the certain task A, okay, faster than the task B. With something simple like that you can easily, clearly can measure them, okay, without any uncertainty in your data interpretation. Okay. So that means that's usually when in experienced experiment designer go in, that's when they miss the first step. They just take it slightly loose and then they couldn't control the outcome later. Okay. Selected subject, so this is related to the target audience, okay, so who you want to test. Some of the VR has some limitation. The full VR headsets is only people who below the 13, okay, 13 years old. Okay, so that means if you're actually going to do for smaller kids, then you have to make sure that you have time limitation for them. Okay, so you don't have them inside there for too long. It could affect them. Okay. And this is variable. So what you want to check. So generally, what we're looking at is, so it depends on how you want to propose. Okay, if you're looking at task A, whether your hypothesis is task A perform faster than technique A perform the same task, but better than technique B, faster, then one of your key obvious parameters is completion time. And that you will list them out. So generally you have a dependent variable, you have independent variable, so that all these design will go into a metric design. Okay. That's why I said before, all this process, planning, designing this, generally take at least 2 or 3 months. Okay. And generally a PhD in HCI would do 3 of these, 3 studies of these things. So I think the first year might get 1, second year might get 1, early third year might get 1. And the method itself, okay, how you want to conduct them, okay, so whether you open field, their movements, okay, how to collect the data, how you input data. I think there's a data collection, data analysis, okay. Because some of the study here, you'll be looking, if just looking for completion time, the techniques, performance, competence, that is an obvious one. But sometimes you go into an explorative component of the study. And that is actually something that really hard to define. Okay, so sometimes you need to have follow this with a semi-structured interview. Okay, that like after done all this, generally VR generally they don't sit down, they just stand up. They put in headset doing tasks. Okay, 2 months ago I done this work with my PhD in New Zealand, based on our VR forest project. Okay, but we got to have a real forester go into the VR set, using our VR for the first time. Okay, so that was the fun part. Okay, each one of them has about an hour in it, the whole process, and total of about 30 people go through, 33, yes. So that thing, and then we're still analyzing data. So part is that design is about a few months. Experiment itself is maybe 1 or 2 weeks at the most, because we require other people to participate. And then data analysis could take even longer. Okay, so right now we still haven't finished the data analysis part. Okay, so data collection different than the data analysis. Data collection is all you can class as raw data. Okay, so you just collect the data, compile the data, make sure you get rid of the anomaly, the thing that you actually it's a mistake. This one is clearly a mistake, and then you kind of lock in a vault in your data folder somewhere to say, okay, this is a raw data, and then you start to analyze. Okay, you have to be very careful not to interfere with data collection in some way, manipulating. Let's say you have a seed of data and you say, oh, this is clearly a mistake, let me change this data manually before you go into data analysis, and that is actually not really a bad practice for research. So essentially you just falsify your data. So that means that your assignment 3, you don't really need to follow anything, even though they say your application has no future. You just write like that. It's no problem. It's a user feedback. It's okay. Yes. You just have to say, why would you Pearson things like that? Hopefully it's not because he hates me or he or she hates me. So, so that means you pick the people that are actually willing to give you a feedback, not the people that say, okay, you can pick me, but I'll give you a bad one. So try to be clever about that. Okay. So hopefully you get the kind of sense. But this one is really routine, based on control, everything control. Okay, everything control, like, okay, you come in, you have procedures. So you come in, you read them consent form, you read them explain procedure, information sheet, explain to them for 10 minutes. If they're happy, they sign off their consent, that they're happy to participate. Then you move on into the actual experiment, and that's go to a routine procedure. And when they finish it, they came out, you check with them, and then you give them a questionnaire, survey to provide feedback, so that when they provide you extensive feedback on what they think of application. Mm-hmm. But again, this is the whole thing here on the day, but actually it's what you design, what you set out to get is really the key. Okay? You get the wrong thing, you can run the experiment, perfect experiment, you won't get anything you need. Mm-hmm. So, but this is, as much as this is a case, some application is actually in the field. Okay, so that you're not actually using, so for this one it might be perfect if your application that you want to test is supposed to be, the end product supposed to be inside the office. Okay, in the table light, for example, this is mostly the case. But in a lot of cases here, it's a few study, especially in the mobile application that you're running, if you're going to do a proper HCI study, having done it in a control experiment is probably not the best way to do it. Okay, it's probably one of the early steps that you can do, but this is ultimately, I think you should get this far, which is a few studies. So that means you test them when they work. Let's say you're creating a supermarket, a new supermarket mobile app. Mm-hmm. Right, so this is a launch, but before you launch to public on the App Store, you probably want to have a test. Okay. So in this case is that you can have people in the beginning and when the early development, you can put them down in the lab, you can ask them, is there any key function here that's missing, is there misleading here, are there anything kind of confusion? You can ask that in the control experiment before. But then that is actually not enough. Usually you have to go into the field because that's what a mobile device, for example, in the supermarket is actually designed to be in that. So this is in what they call a natural stage or setting. Okay. So this is how people are using, let's say this is so they should be living in the normal life, in their normal routine, and this thing will come up. But the key for this one is nothing control at all. I mean, all things happening around you, there's no control, and you're not actually walking around with the guy, with the participant. You simply set and go. Okay. And what that means is that these require a lot of back-end tracking. Okay, so for example, the mobile apps, you have to get a consent that you be tracking their movement, behavior, and privacy could be the key issues. Okay, so but that's you have to be upfront to participant. You can't tell them, oh, nothing will happen, but you actually track them while you sleep. You're tracking everything, and those will be a bad thing if they start complaining about that, privacy and thing. So in this case here, you require a lot of that when they're doing, because now each of their participants, let's say you roll out into this, there was study part of SenseT a couple of years ago on a tourist app that it introduced here in Tasmania. So they give an incentive by giving a voucher or that kind of thing, but essentially they have to hand them a phone. For foreigners, when they land in airport, they participated, they hand them a phone. Before they leave the island, then they return the phone and they get their reward voucher. So with that, they ensure that they can track everything from there. Okay. Where they go, I think that's one of the way that they're using. That's why they notice how the traffic are going between the tourists. You know that tourism in Tasmania has been booming in the last few years. It's been a major kind of income for the state. Okay, but that means that they just want to, the business people want to understand how the traffic flow inside the island, how people go, which one they go, which one, and try to explore which one is still underutilized. Okay, maybe we should promote this place more because not enough people go there, or not, it should have been more people go there. But this one is that's what its natural settings look like. So you go into the space, you have them play, but then you have to have ability to retract the data. Of course, you will ask them at the end of the trial. You will ask them what they think, okay, what they like about it. But at the same time here, you need to collect your quantitative data, which is actually from the back end, how they use it, when they used it, okay, how long they used it, okay, how many times they used it. Does it make sense that you use this? Maybe some button technically it doesn't work. So for example, so they end up, you're tracking, they call data logging. You end up that, okay, that button had been checked many times, and this action between button number 7 and button number 5 seem to have quite a few try. They keep back and forth, so that means it potentially is a problem with either with the phone or with the apps. Okay, so you will detect those kind of things. Okay, but this is the kind of very powerful. This is quite difficult, probably the most difficult to do. Okay, so that means you should have done the previous step before, the control experiment, which is not exactly aimed at the same thing here, because it's not in a natural setting, okay, but you gather the core component to develop. So these you're talking about probably get here by about 3/3 or 4th design of your application before you even land here. Okay. And this one is the one that usually you don't see. Okay, so this one is more prediction component, predictive algorithm. This is when you start to know quite a bit. I think I talked about this before. How to move in 2D now is really quite mature. Okay, but in most of the VR AR field, this one it doesn't really exist. Okay, it's because it's basically we don't have enough data. We're still exploring what can do inside VR, but this is more mature sense. So you have now experts that apply their knowledge of extensive knowledge of over a long period of time. Okay, so they guide by heuristics and to predict usability problem. Okay, so in this case here, if you design a new app that based on a framework, let's say in this case, is a fit law is one of the good example that actually used to predict how far you can travel between distance. This is for the on the monitor, mouse, keyboard, using mouse keyboard interface. And that field had been studied for since the 80s, so it's had a lot of data. Eventually, be able to form this kind of equations. So, capital here, all you have to pay attention to is T is the time, capital T, and capital D is diameters, the size of that, and the distance. The capital D is the distance from one you travel, and the W here is the width of the target in which you travel to. So this is actually equation to predict how you travel from here, from one part of the monitor location X, Y, going to a different part of the monitor where supposedly your target icon is. So that's it actually used to give you an idea of what the target size should be. Let's say you decide with this, but the time is, you want to detect that, okay, if you have icon this much, 5 centimeter width, okay, and you have the distance to travel maybe 10 centimeters. How long does it take? And then you can use the equation to calculate, to predict this is most likely how long it's predict. Okay? So what that means is that you can feedback in the design whether that's the whole life of your application, that you have to travel like this, click button here, what is efficiency in the task in each one that you design, whether it fit with what you need. Okay. And it only gives you the reason the predictive is useful is that instead of you have to run another experiment and try to see how long people take, you can use this to predict. It's a simple equation there, so it gives you a guidance. Okay, it's not 100%; it's still predictive. Okay, but based on a lot of data. Okay, so it's relatively confident that it's robust enough. So what that means is that it shortens that part of forest, so that you say, okay, this time is way too long than acceptable range. We need to change the design. Yeah, so then you adjust, either you adjust the width, or you adjust the width of the target, or you adjust the distance, make it shorter. Inside that to fit. And this equation can be refit on something else. For example, if you have a fixed the width and you have the fixed timeline, you say, okay, the task require this four click in the 4 button here, require no more than 3 seconds. Where should I press that button? Where should I press those buttons? Well, how distant they are. So you can use this equation to calculate those. So this is the kind of example when the field getting more mature. In VR, this is still a bit difficult. Okay, this is still doesn't exist as far as I can see. So, but this is something that that's kind of useful. Okay, so require not user experiment. You can see the users actually not have to be here. But it's a very good, powerful one. Now, some of the case study here I'll show you. Okay, so let's see. Okay. So the first case here is my own projects. Okay, it's called Ghostman. Okay, so this is from 5 years ago. We set out to do with health science to do rehabilitations, visual guides using AR system. So the glass here he has a camera attached to it, and you can see the 2 eyes. So basically, you can see the real world image, but in 3D, sort of enough 3D. But field of views, everything is just as the technology allows. But the camera field of view is so short that you can't really extend to the limbs too much. So that means you can't really see them effectively. So basically, we convert our study a little bit to be teaching how to use chopstick instead. Okay. So what that means is that they not eating noodles, so they're just moving a Lego piece inside a bowl. They have about 20 Lego pieces, small pieces, in one bowl. Their task is to move from that bowl to the left bowl. And what we're counting, we record the video of how they perform tests. And the application here, there are 2 people here, because the term Ghostman means what he see, he's my honor student, master student do thesis, and that's his partner. Okay, so what that he says, this is about teaching novel skill. Okay, instead of you teaching the therapist teach them how to move their legs and how to move their muscle when they try to do rehabilitation, this one just teaches people how to use chopstick. Of course, participant in target is people who never used chopstick before. So we have to find mostly they're not international students, mostly very hard to find those. But yeah, so basically, essentially here, the system is actually allow you to see from the expert. He's supposed to be the expert one. So his camera is showing his hand. Okay, I capture his real hand, but at the same time he has an overlay image of what he actually see from the other side. So he can see how the trainee hands look like. So he tried to use his hand to guide them, just like he has a ghost hand in front of him. And then from her view, from the trainee view, it's the same. They see a trainer hands kind of on top of them to try to show them this is how you use the chopstick. Okay, but remember, it's not instruction. It's just kind of you see your real hand by the camera, but then you see a ghost hand kind of on top of it. Mm-hmm. It look a little creepy, but it looked like that. So remember, this is 3D. Okay, so that means you will see the sense of depth a little bit. So you see the real one, a darker hand. A ghost hand, of course, the ghost being ghost is a little pale. The hand's a little bit pale there on the top, the ghost hand. So in that case, you kind of get lining up a little bit there. Okay, so what we try to do here is we compare this. This is a teaching novel skill. Okay. In this case, chopstick. Okay, it's a novel skill, which most of your case is probably not novel. But for some of these, we managed to find, can't remember, 10, 15 of them that never used chopstick before, around the Newham campus. So we put them here. Okay, so the comparative case for this one is actually compared to face-to-face. had a brochure, a small instruction, and then you sit kind of next to each other. So he would take off his headset, and he would sit next to the participant, and teach them directly. Again, this is how you do it, just like your parents teach you how to use that. So they will compare the two cases. Okay. So the navigation key will just give you the idea whether the hand is, because the funny part was the tracking is not that good. So what that means is that we can't really access any tracking. So that means the guy could be looking slightly in an empty area, your hand is still floating there. So those navigation to make sure that you align your hands and his hand. So this is more or less for the trainer to make sure that he can use the system. Okay. Our things is to looking forward, actually learning new skill, whether the new method, which is AR thing here, goes man, and versus face-to-face. What the impact of the learning skill. And the key parameter for us to measure is how many errors they made. So as I said before, you have 20 pieces of Lego, you just move to a bowl. How many times you clip and then it slip off your grip, or how many times it drop in the middle without going to the other bowl. So you're counting every single thing of that. And that becomes your vertical axis there, so the total errors, skill errors, so how many drop. So, and what we want to look at it is also retention, which is another key, is that because sometimes you can get learning very quickly, like you never try to imagine that you never used chopstick before, and then suddenly you got to learn it within that 45 minutes, and you got to test it right after. And generally, sometimes it's okay, but sometimes people learn quicker. Yes, but the thing is they forgot afterwards. So that's what the retention for is 24 hours and 7 days later. So we ask the participant to commit that. So 24 tomorrow, when you're done experiment, the main experiment today, come back tomorrow, come back another week, a week later to do the same test. Okay. And in the red one here is skill error for the ghost man. For the face-to-face in orange. Okay. Yeah, you can see here, we could easily misinterpret this as a ghost man actually allow them to perform better. When in fact, if you look at it, this is probably around 8 total error on average, okay, compared to 6, which is a very small one, okay, compared to the total range, it's a high length of more than 14. So that's a very small amount. But what we actually hypothesis that we set out to do this is that we think we set our hypothesis as ghost man is as good as face-to-face. Okay, we never really pitched the hypothesis that ghost man, the new technology, is going to be better face-to-face. Okay, so that is carefully, strategically put there, because that would be an argument that actually very difficult to really justify. Because what you're talking about here, because the reason they're sitting here is actually they not communicate directly. They actually go through the internet, even though their physical room is just kind of opposite side of the room. But in fact, these could be one in Melbourne, one in Tasmania. So this could be a totally changing. But this is a focus on a small skill. But this is what people focus on a lot, what they call teleoperator, remote teaching, normal skills. A lot of this work is extremely difficult. For example, you can teach new skill to a new doctor, inexperienced doctor, from a distance. So that would sell a lot. That's what Australians are having some of the issues here. People in remote, doctor in a remote area, over time their skill will drop. And then there's no more sensible way to get them to reacquire new skill. So some of these could be very useful there. So as you can see here, the retention, it's also another thing we're looking at is that retention here, doesn't drop. Usually the effect is actually about experience. Generally mean, it's high, but then you see as a second time it dropped quickly. So in this case, you can see the level of retention, which is how well you retain. The same thing is here, what you remember now when you go to exam, that measure your retention from your class. So you can see here, this thing after pre-ex test, and that is a relatively so you don't have skill here. You can see here, this one, and then you start to make more mistakes. Apparently, somehow training make them more mistakes. And then they start to drop a little bit after 12 so that means they're getting slightly, hopefully better. But generally what they expected, that this one it actually skill errors that go up after retention. So that usually is mean. But what that means is that the 7 days is actually allowed you to give whether that's a stable. If that's stable, that means the skill is getting to you. Okay. Generally, if it's go up like that, go up in the skill error, that means what you learn you tend to forget. Yeah. So and that is one of the things that we think is okay. It's a good. The reason this is also a strength for showing you the the case of the face-to-face, because face-to-face is what we do in the normal life for this type of training new skills. So this one will allow you to do slightly close in terms of pattern. So there's quite a few things that we publish. We publish in journal. So this is one of the work. This is another work from the intern from Thailand, looking at building a project around the smartphone interaction with the public display. This is a couple of years old of work. So you have mobile phone, you have all the screen. This is a hit lab that we built. Okay, you have this system in Hobart next year. Okay, I'm helping building them. So basically, it's advertising mode. Okay, so they can move around. So in this case here, you will be able to interact with that the big size, wall size. Let's look at the video. You can see here, you use a mobile app to control the big size. So this is what I think her study was focused on, how people are engaging with the public display, okay, where you now just see them as advertisement, but now we're projecting in this case that you can interact with it, okay. You can drop the message, some things like that. So this become more, as a big screen become more available. It's maybe a place instead of you just look at monitor, just your small screen, you now can socially participate on the big screen. But you have you need a mechanic to interact with those big screen. Okay, so that's give you some idea of what the study. So the study quite extensive in that area. So this is we published about 3 papers on this one. So this is an event score, okay, on the horizon here, and then you have number of browsing. So you should tell. The key part here is this is about 20 participants. Each dot tells about what the score, how much they get. They'll be giving a question, for example, can you tell me how many events, because there's total of 20 events, how many events of this is about running 5 kilometers events that you want to find? It's advertising, you want to draw the information out. So you start to check how many people get it right, how many get it wrong, how many they say, because we can ask them to tell that afterwards, okay? So they'll be looking at that, so you can see how many browse. So in this study, it showed that the browsing is actually, the more you browse using the apps, the more you score high, okay? And also one cluster at the bottom left there show that if you actually score low, you never actually, if you browse, the one that actually missing here, the one that here, where's my mouse? It's this part, okay? This part doesn't exist, allow us not to be able to conclude that actually, if you have a browsing low, you will get, if you score high, you get a browsing low number. So this is where actually the data difference, okay? So this is a gap where actually we make a lot of insight into analysis data. Okay, so you can have a look at it and see what the meaning is, and then if you're interested, you can look at the paper. All right, so I think my time is up. Any question? So hopefully it gives you some idea, but this is not the assignment 3 that you'll be doing. Okay, assignment 3 is a quick and dirty part. Yeah, so that's a quick chat. Just be careful about the question you want to ask, and then that's it. All right, so thank you.